Lal Bahadur Shastriji. It gives me immense warmth and great pleasure to grace all of your presence in the interest of the entire committee. It gives me tremendous commitment to be presenting the welcome speech amongst the most esteemed personality. Here, I will first start from the quote of our great Gandhiji. I offer you peace. I offer you love. I offer you friendship. I see your beauty. I hear your need. I feel your feelings. My wisdom flows from the highest source. I salute that source in you. Let us work together for unity and love. And ISS is the organization which always again doing the good things. And in this pandemic situation also, we are trying our best. Webinars are organized and conducted for the audience to gain insight and information that would remain effective in their life, exercises and work. Therefore, the topics for today's discussion is also related to this bridging the gap between Vedic and modern sciences, non-centric characteristics of typical Ayurvedic bhasmas by using ultra-modern analytical techniques. For this, amongst us, we have a speaker, Dr. D.P. Amarnerkar sir, Professor Emeritus, Technology Department, SPPU. We have again Chief Guest, Dr. S.F. Patil, former Vice President, Vice Chair, VC, North Maharashtra University and BDDU. Our beloved President, Dr. P.P. Chandrachudan, Vice President, ISS, Dr. Raghveswaran, Dynamic Chairman of Pune Chapter, Dr. Nilima Rajurkar, Secretary, Dr. Avinash Kumar, and Treasurer, Dr. Sunil Hande. With this, I welcome you all. There are other dignitaries on the dais. The special welcome is to Dr. Garg sir, then other dignitaries also. I welcome you all and I wish you all a very successful webinar. Thank you. Over to you, ma'am.
Thank you, sir, for the warm welcome. Light symbolizes the victory over darkness and ignorance. Deep Prajalan marks the beginning of any event. So I request all dignitaries to lighten the lamp virtually. Thank you all. Now I would like to request Dr. Parag Adhyapak from CMED to introduce Dr. Rajurkar, Chairman of ISAS Pune Chapter.
Thank you. Good evening all. It is my immense pleasure to introduce Professor N.S. Rajurkar, former professor and head Department of Chemistry and former Department of Environmental Science at Savitribai Phule, Pune University. With a teaching experience of more than 39 years, he is a fellow of Maharashtra Academy of Sciences and has been working in multidisciplinary areas such as nuclear and radiation chemistry, electrochemistry, neutron activation analysis, environmental pollution, wastewater treatment, medicinal plant chemistry, synthesis of ayurvedic bhasma, radiopharmaceuticals, public health, etc. Through her research career, she has guided 16 students for MPhil and 30 students for PhD degree and has more than 200 research publications to her credit with H index 20 and I10 index 36, over 1800 citations. She acted as the editor of international journal Clean Soil, Air, Water of Ville Blackwell and also as a peer team member of NAC. International Biographical Research Center at Cambridge, UK has listed her amongst the leading scientists in nuclear chemistry in 2009. And Indian Council of Chemists confirmed her with Professor Kaza Somshekhar Rao Award for Best Woman Scientist in Chemistry in 2014. She has written a book, Nuclear Chemistry Through Problems, with Professor H.Z. Arnikar, and she is also co-author of a book, Science and Technology for Competitive Exam Students. She was involved in preparing a series of video films in radioactivity and a lecture series on environmental science for UGC countrywide classroom. She visited many countries like China, Denmark, Italy, Germany, France, Belgium, UK, etc. for invited talks and conferences. She was the referee for PhD thesis from number of universities and institutes. She has delivered more than 100 invited talks at various universities, colleges, and institutes all over India and abroad. She was the vice president of Indian Association of Nuclear Chemists and Allied Scientists and convener Indian Women Scientists Association, Pune branch. Presently, she is vice president of Marathi Vigyan Parishad, Pune Vibhag. She is a member of number of scientific societies. She is actively involved in science popularization program, and as a part of it, she has recently written a book on radiopharmaceuticals, diagnosis and therapy in Marathi. Thank you.
Thank you, Dr. Parag. Now I would like to request Dr. Nilima Razurkar to brief you all about Pune chapter and introduce our chief guest, Dr. S.F. Patil sir.
Thank you, Parag, for your kind words. Good evening to all. Today's chief guest and my guru, respected Professor Patil sir. Today's speaker, Dr. Ammanekar sir. President, Dr. Chandrachudan. Vice President, Raghav Saran. Chairman, Webinar Committee, Rajiv Raghavan. Nagpur Chapter Chairman, Dr. Avinash Bharti. All EC members, chairman chapters, senior members, Dr. Gar especially, he joined on my invitation, and my dear participants. It is my pleasure to welcome all of you in today's program. First of all, I would like to thank Dr. Saran sir and Dr. Vijay Adda madam for motivating me to start this chapter. I'm also thankful to Dr. Chandrachudan sir and all EC members for giving us permission to start our Pune chapter. So I'm glad to mention here that as of today, we are having 52 members. In the morning, I informed Saran sir that we have reached 50 now. It is 52 is the number. So we have all these dynamic members from different fields, and they are from different university departments, different national institutes such as NCL, CMAT, ARI, IITM, DIIT, and so on, from colleges, industry, as well as from the hospital. So we are having a very good team at our Pune chapter. And I'm sure with this dynamic team, we'll definitely achieve the goals which are set by Indian Society of Analytical Scientists to promote the excellence and bring the innovation in the scientific fields. So we have decided that is our aim is to reach all the sectors of the society, right from school students, PG, UG students, PhD students, teachers, then general public, scientists, and even at grassroots level. So we'll be arranging the lectures by eminent scientists, workshops, seminars, conferences, awareness programs, and science popularization programs. And today is the beginning of it. So that is in short about what we will be doing. And I'm thankful to my organizing team who are working for almost last 1 week with me. I'd like to thank Dr. Avinash Kumbhar, who is the secretary, Dr. Sunil Hande, who is the treasurer. Then other members, that is the organizing team members, they are Pooja, Samir, Parag, Sunil, Manisha, Swarna. And here I would like to give my special thanks to Ameya Adhyapak, Sri Ganesh Marathe, Dr. Parag Adhyapak, and Samir Onkar. So they are cooperating me in preparing this ISAS quiz. So I want to give their special thanks to them. Now about today's deep test. I feel honored to say a few words about my guru, Professor Patil sir. He is a great teacher, excellent researcher, and a very good administrator. So he was the student of Professor Xray sir, legendary in the field of nuclear chemistry. So at that time, there were 3 generations of nuclear chemistry in our department. Onika sir, Patil sir, and myself. That's why I could do something in this particular field. Patil sir has guided 35 research students for their MPhil and PhD degree, have more than 200 research publications. He worked in different diverse fields, nuclear and radiation chemistry, environmental science, nanoscience, electrochemistry, and so on. And now a lot of work he has done in the education field. So first he was professor and head at our chemistry department in Pune University, and he worked for all-round development of our department. Then he joined North Maharashtra University as Vice Chancellor. There he started several new courses. Then he developed several infrastructural facilities there. And one more thing which is very commendable is the plantation of 1 lakh teak plants. So that shows he is a true environmentalist. Then he joined the Vice Chancellor at Bharati Vidyapith, where he helped in further progress of that university. Then he was holding several prestigious positions. He was president of Indian Association of Universities, Maharashtra Arogya Mandal, vice president of Indian Association of Nuclear Chemists and Allied Scientists, MACS. Then he was a president's nominee on number of central universities. He was pro-chancellor of Singhania University, and he is recipient of several awards. To mention a few: Jeevan Sadhana Gaurav Puraskar by Bharati Vidyapith, Dr. Ramaiah Lifetime Achievement Award by INCAS, then Best Teacher Award by Pune Municipal Corporation, Professor Frederick Gerio Curie Endowment Award by Pune University, so and Vanashri Award by State Government. So he has several laurels I can speak on, but due to short of time, I told something only in brief. And I'm proud to be his student. He is a role model for us. Thank you, sir, for joining with us.
Thank you, ma'am. As we gather on digital platform for the inauguration of Pune chapter, I would like to request Dr. S. A. Patil sir to inaugurate Pune chapter and present inaugural address.
Hande sir? Hande sir, एक काम मी आता नको करू present. पाटील सर अनम्यूट. पाटील सर अनम्यूट करा. अनम्यूट करा सर.
Is it okay?
हाँ.
Yes, sir.
Yes, sir.
Shall I start from the beginning then?
Yes, sir. Yes, sir.
Yes, sir. Start from beginning.
Okay. Good evening to everybody. Honorable Dr. Chandrachudan, President of ISAS, Dr. Saran, Vice President of ISAS, Dr. Nilima Rajwekar, Chairperson of the Pune chapter, Dr. Bharati, Chairperson of the Nagpur chapter, Dr. Amal Nirkar, Professor Emeritus, Dr. Avinash Kumbar, Secretary of the Society, other dignitaries of the organization, ladies and gentlemen. At the outset, let me express my gratitude to the organizer for inviting me to be chief guest to inaugurate the Pune chapter of Indian Society of Analytical Scientists. It is undisputed fact that analytical chemistry is the most important branch of science, not only limited to the various branches of chemistry, but also to the biological sciences, engineering, and more recently, medicine, public health, environment, agriculture, and supply of energy in all forms. Scientists and technologists need not only to establish the identity of the materials, but also to quantify their composition and purity, and to measure the contamination at the nanogram level. If you examine the history of analytical chemistry, it began in the late 18th century with the work of French chemist Lavoisier and others. It has grown and developed tremendously in the present years. No experimental science can avoid analytical chemistry since it strongly contributes to the progress of the respective branches of science. Among all the scientists of analytical sciences, Coulthard is widely regarded as the father of modern analytical chemistry due to his extraordinary contribution in this field. Friends, you will agree with me that the modern analytical chemistry is determined by the instrumental analysis and has become a multidisciplinary subject encompassing all branches of experimental science, including automation and robotics. Research in analytical chemistry is largely driven by the performance parameters such as sensitivity, detection limits, selectivity, accuracy, precision, and the cost. Analytical sciences plays a very critical role in understanding the basic sciences and has a variety of practical applications ranging from all branches of chemistry, geology, agriculture, pharmaceuticals, biomedical applications, environmental monitoring, quality control of industrial manufacturing, forensic science, archaeology, space science, genomics, DNA technology, nanotechnology, and many others. A large number of analytical techniques are now available. However, its choice depends on the number of parameters such as required precision, accuracy, sensitivity, specificity, matrix effect, non-destructiveness, multi-component capability, and the cost. Accordingly, one has to select a proper technique such as NMR, IR, NAS, ICPS, HPLC-MS, GCMS, ACM, XRD, and so on. Nowadays, the miniaturized analytical instrumentation has been developed, which is based on the concept of chip technology, such as lab on chips. This has revolutionized the analytical chemistry from macro to micro to submicro to ultra micro and to single cell level. I'm glad to know that Indian Society of Analytical Scientists is playing a very important role in promoting the excellence in right direction by providing top-level analytical expertise in analytical sciences. It has established several chapters in all over the India. I'm happy that the chapter of this society is now launched at Pune. Today's webinar is organized on an important topic called Bridging the Gap Between the Vedic and Modern Science, a nanocentric characterization of typical ayurvedic bhasmas using ultramodern analytic technique by Dr. Amalnekar. All of you are aware that ayurvedic bhasmas are integral part of the ayurvedic medicine and are prepared from inorganic compounds or elements. Several processes are adopted to convert inorganic compound into sub-biosuitable forms. During the process of synthesis, various types of toxic minerals are removed from the original compounds to minimize the toxic minerals and thereby avoiding adverse effect on the body. Improperly prepared bhasmas, if used chemically, may produce potentially severe adverse effect on the human body. Therefore, analysis of these bhasmas is mandatory for safety evaluation. Hello, are you able to hear me?
Sir, please.
Yes, sir. Continue, sir.
Yeah, we can hear you.
As a consequence of the huge diversity in synthetic procedures, it is difficult to know whether the bhasmas are prepared by different methods is identical or variable. Unfortunately, no significant and systematic work has been carried out from this point of view. Due to the increasing popularity of Ayurvedic medicines, the large number of Ayurvedic pharmacies are rapidly expanding. Just hold on. I think somebody has come. Just hold on. I'm sorry. My grandson has come, so I have to take. I was referring that due to increasing popularity of Ayurvedic medicine, the number of Ayurvedic pharmacies are rapidly expanding for their commercialization of the reputed Ayurvedic drugs. Therefore, an examination of different commercial samples using modern analytical techniques is the need of the day. A survey of literature shows that most of the studies on bhasma are carried out using commercial samples, and there are only few reports on actual synthesis and characterization of bhasmas. I'm happy that some of the researchers from Pune chapter itself are working in this particular area. I am aware of the research work conducted by the Professor Rajurkar on various bhasmas for their elemental analysis using activation analysis technique. This technique was developed by the chemistry department of the University of Pune, then University of Pune, using californium-250 source and HPG detector. Number of bhasmas in their group were prepared by traditional methods from metals. The characterization was carried out at every stage of preparation. Neutron activation analysis has helped them to know how elemental form gets converted slowly into the oxide by determining the elemental concentration. FTIR helped them to conclude a herbo-natural nature of the bhasmas. The morphology and nanoparticle formation in the synthesized plasmas were studied by using XRD, TEM, DLS techniques. I'm also aware of the work which she carried out on the ancient coins using these non-destructive techniques, and is published in the form of several papers in the international journals. Dr. Amalekar, Professor Emeritus of the University, is a former executive director of CMET, is well known for his extraordinary contribution in the field of electronic materials and devices, nanoscale materials, and nanobiosciences. Today's webinar will demonstrate his contribution in the Ayurvedic bhasmas by using the most advanced techniques. Lastly, the ISAS Geet composed by Professor Rajurkar is appropriate in tune with the ISAS aims and objectives. I wasn't aware of her poetic talent so far. A background music was provided by her son Maitreya and sung by her nephew Parag. I am very happy to inaugurate the Pune chapter of ISAS and also declare that ISAS Geet by Pune chapter is released. I request the organizers to present the Geet. Once again, I thank you, all of you, for inviting me a chief guest for this function. I do hope Pune chapter will play a major role in the activities of the parent ISAS society. Thank you very much.
Thank you, sir. I appreciate you taking the time to share these valuable information on analytical sciences and Ayurvedic medicine. Now it's time to release ISAS Geet, as Dr. Patil sir mentioned. Geets prevailing lyrics by Dr. Rajurkar, melody by Dr. Ganesh Marathe and Dr. Samir Omkar, sung by Dr. Parag Adhyapak, and had a music by Dr. Ameya Adhyapak. I would like to invite Dr. Hande to play it. Dr. Hande, can you please play it?
Yes, ma'am. Yes.
ISAS है हमारे भारतवर्ष की शान, ISAS है हमारे हमारे भारतवर्ष की शान, इसके सदस्यों का कार्य है महान। ISAS
Yes, madam.
हमारे भारतवर्ष की शान, ISAS है हमारे भारतवर्ष की शान। भारत भर में फैली हुई है इसकी अनेक शाखाएं, एक धागे से बंधी गई है ये तन मन से।
Please give us
विश्लेषण विज्ञान हर शाखा में है
हेलो।
अहम, मूलभूत उपयोजित विज्ञान का है ये संगम। परमाणु ऊर्जा अवकाश, परमाणु ऊर्जा अवकाश, आरोग्य खेती जैव विज्ञान। परमाणु ऊर्जा अवकाश, पर्यावरण नानो विज्ञान आदि विषयों में है काम। ISAS है हमारे भारतवर्ष की शान। हर दिन ऊंचा हो रहा है ISAS नाम, हर दिन ऊंचा हो रहा है ISAS नाम। कार्यशाला सम्मेलनों से बढ़ता सबका ज्ञान, हम सबका गतिशील सहभाग लाता है इसमें जान। ISAS है हमारे भारतवर्ष की शान। छात्रों शिक्षक शास्त्रज्ञों का आगे बढ़ता काफिला, मन में ये उम्मीद जगी है, मन में ये उम्मीद जगी है, बढ़ता रहा है हौसला, दीप स्तंभ बन जाएगी, दीप स्तंभ बन जाएगी। ISAS 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 है हमारे भारतवर्ष की शान। ISAS है हमारे भारतवर्ष की शान। भारतवर्ष की शान, भारतवर्ष की शान। ISAS।
please give a round of applause for such a wonderful song of ISAS. Thank you all. Thank you all again. May I now request Dr. Chandrachudan, President ISAS, to deliver his President's address.
Good evening to all. Beloved Professor S.F. Patil, today's chief guest. Dr. Dinesh Amalnerkar, today's eminent speaker. Dr. V.R. Nair and Dr. N.K. Pillai, former presidents of ISAS. Dr. Raghav Sharan and Dr. Rajiv Raghavan, vice presidents of ISAS. Professor Nilima Rajurkar, chairperson of Pune chapter and her efficient team in Pune. Chairman of all the other 8 chapters of ISAS. Members of the executive committee of ISAS and the entire nationwide fraternity of ISAS members. Kindly accept my sincere greetings on the occasion of Gandhi Jayanti and Shastri Jayanti, which henceforth also going to be the Jayanti of Pune chapter of ISAS. On this occasion, on this historic occasion of the birth of Pune chapter of ISAS, I would like to extend my heartfelt congratulations and best wishes to all my esteemed scientific, academic, research, industrial and innovative entrepreneurial colleagues in the Pune region of our great nation. Friends, it is very befitting to this occasion that we have Professor S.F. Patil, Executive Director and former VC of Bharatiya Vidyapith and former VC of North Maharashtra University, Pune, as the North Maharashtra University of Jalgaon, as the chief guest to inaugurate the ISAS Pune chapter and the excellent webinar that is going to be presented today. A world-renowned nuclear chemist and a widely acknowledged educationist, Professor Patil is at par with the great stalwarts of India in nuclear chemistry who shaped up the Indian nuclear program. His magnificent presence today with us in the evening is indeed adding to the great glory of this evening function. On this occasion, I also request Professor Patil to continue to support and advise the ISAS activities of not only Pune chapter, the headquarters as well, so that we can make many vibrant programs. Thank you, Professor Patil, for joining us as our chief guest today. Professor Dinesh Amalnerkar, Emeritus Professor at the Department of Technology of Savitribai Phule, Pune University, and former Director General of the Center of Material for Electronics Technology, that is known as CMET of Government of India, is a very reputed Indian technologist of international caliber. I had an opportunity to interact with Professor Amalnerkar through the CMET Thrissur in an opportunity to interact in my role as the BRNS R&D program coordinator, in which a high impact engineering product of far superior quality, much better than the imported product from the USA, was developed by CMET Thrissur and used in many strategic programs in India. Dr. Amalnerkar is speaking today about a very essential area of activity that is key to support the modern scientific credibility to the time-tested and widely benefited systems of Indian medicine. Therefore, I look forward to the talk by Dr. Amalnerkar with very personal and very keen interest. And in between, I had sample discussions with many eminent experts in the Pune region, and I am sure that the Pune chapter of ISAS is poised to embark on many useful activities that would make a high impact in the academic R&D and innovative activities, as well as dissemination of scientific information and to build the scientific temperament. The ISAS Geet, which is composed by the Pune chapter, is only a trailer of the things that are going to come ahead. Friends, at this moment, being a Mumbaiker, I try to be a little parochial. या दिवशी जेव्हा ISASच्या पुणे चॅप्टरच्या जन्माच्या या ऐतिहासिक प्रसंगी मी पुणे विभागातील माझ्या सर्व आदरणीय वैज्ञानिक, शैक्षणिक, संशोधन, व्यावसायिक आणि नाविन्यपूर्ण उद्योजक सहकार्यांना आपण सर्वांना माझे हार्दिक अभिनंदन आणि शुभेच्छा देऊ इच्छितो.
Thank you, sir.
I am not at stop today. By the grace of my Sadguru, I wish well for the Pune chapter of ISAS in the times ahead and many excellent activities that will be winning many laurels. Thank you very much. Thank you very much. Please go ahead.
Thank you very much, sir, for your remarkable address. I assure that Pune chapter and future definitely conduct the excellent activities under the guidance of all eminent scientists and professors from the diverse fields. Now I invite Dr. Raghu Saran, Vice President, ISAS, to give his remarks.
Honorable ISAS, distinguished luminaries, Dr. Asif Patil, today's chief guest, Dr. Amalnerkar, today's speaker of international repute, Dr. Nair, Dr. Pillai, Dr. Rajiv, Chairman Webinar Committee, Honorable EC members, Dr. Bharti, Dr. Rajurkar, Chairman of Pune Chapter, Dr. Avinash Kumbhar, Secretary, Dr. Sunil Hande, and all Treasurer and all life members of Pune Chapter. and my dear all friends, warm greetings to each one of you and a very good evening to you all. Today, as we all know, is a very special day, birthday of two unparalleled commemorative personalities of country. Mahatma Gandhi, who said, I will not stop till I don't wipe the tears from each eye. So such a great philosophy he had. And father of nation, and Shri Shastri Ji, our beloved Jai Jawan, Jai Kisan Prime Minister. And friends, we are proud to share their birthday along with Pune chapter's birthday. Today, in garden of our society too, a new flower has blossomed, Pune chapter. Usually, blossoming too goes through several phases. First, a bud, and then it blossoms into a flower. First, ad hoc status, and then full-fledged status. But in this case, we are planning for an ad hoc status, ad hoc chapter, but already the need of minimum members has completed by this morning. It is all because of great dynamism of Dr. Nilima Rajurkar, her great dynamism, the moving spirit behind the pursuit, her encouragement, inspiration, and motivation, which saw this early fulfillment of the requisite number of life members, and even organizing a talk on the same day. Not only this, she has a hidden talent of composing a lyric, such a wonderful, beautiful lyric. I feel this is the first time in the history of ISAS that a lyric has come in the name of National ISAS Geet. So thank you very much, Rajurkar. I want to congratulate you on the feat and all the members of the chapter, Pune chapter. Pune chapter has several old members also, and I'm very sure that their capabilities, their talents also will be utilized by Pune chapter. The old bloods, they guide you, and new bloods, new and young bloods, they survive and they take out the chapter ahead on the path of progress. I would request each one of you to provide your utmost support. All life members, I am addressing to all life members of the Nagpur chapter, and add new dimensions to its activities. If each one of you support Rajurkar's goal, nothing can stop you. I wish you all on the occasion a hearty success and best of all, nothing else. Thank you.
Thank you, sir.
Thank you, sir, for such an insightful words and appreciation to ISAS Pune chapter. Next, I would like to request Dr. Rajiv Raghavan's Chairman, Webinar Committee, to address the digital gathering.
Good evening to you all. First of all, I want to congratulate all the members and office bearers of the newly installed Pune chapter, and also congratulate Dr. Nilima Rajurkar and his team for that making that ISAS Geet. And also I want to congratulate Dr. Raghav Sharan and Vijayalakshmi Adya for instrumental in the formation of this chapter. Indian Ayurvedic compositions are wonderful medicines and always fascinated the world by its therapeutic properties in curing diseases. The metal-based Ayurvedic compositions called bhasmas are a special class of medicines in which metals and its compounds plays an important role. Mercury, arsenic, lead, the non-highly poisonous materials are often used in this composition. The structure, morphology, and the chemical composition of these systems are still unknown, as well as the mechanism by which they are working in our body. This is a highly interesting but tricky and involved area for an analytical scientist to explore. Luckily, today we are going to hear about this from none other than the expert, Dr. D.P. Amalnerkar itself. Thank you.
Thank you, sir, for your speech. Now, without further delay, we will turn time to today's expert, Dr. Amalnerkar sir talks. Before we get started, I would like to request Dr. Avinash Kumbhar, Head of the Department of Chemistry, SPPU, and Secretary Pune Chapter, to introduce today's speaker, Dr. Amalnerkar sir.
Thank you, madam, and good evening to all on this very auspicious day. And I would like to, with the great respects to Dr. S.F. Patil and Dr. P. Chandrachudan, and all the dignitaries on this digital platform of ISAS, thank them for giving us permission to start this Pune chapter. And it's a great pleasure for me to introduce our invited speaker today, Professor Dinesh Amalnerkar, presently the Emeritus Professor at the Department of Technology, Savitribai Phule Pune University, and former Director General of CMET under the Ministry of Electronics and IT, Government of India. Dr. Amalnerkar has his initial education, BSc and Master's degree from Shivaji University, followed by a PhD from the National Chemical Laboratory, affiliated to the University of Pune then, and has several professional positions starting from a research scientist at ILPRO International to research scholar at Gifu University, pool officer at National Chemical Laboratory, and then senior scientist at CMET, and was visiting scientist at several universities, including Gifu University, Japan, and brain pool invited scientist at Korea Research Institute of Chemical Technology, director of CMET, director general of CMET, CEO of CMET at Pune, Hyderabad, and Thrissur centers. He has several short-term visits, assignments in Japan, Singapore, Switzerland, Saudi Arabia, Slovenia, and Bulgaria. Professor Patil also mentioned his research interests: electronic materials, nanoscale materials, nanobioscience, science, and energy materials. And he is several papers, more than 230 publications in international journals with an H index of 39, citations about 6,500, 24 Indian and 3 US patents, 3 of which technology has been transferred, and has given more than 100 invited talks in India and abroad. He has also other professional activities, such as past president of Material Research Society of India, Pune local chapter, and has organized more than 14 international symposia, workshops across India and abroad. A member of several statutory bodies of various universities and government funding agencies. He has several awards to his credit. I would just like to mention a few. He is elected Fellow of the Maharashtra Academy of Sciences, recipient of the medal by Materials Research Society of India for outstanding contributions in material science and engineering, and is a 3 times recipient of the prestigious Brain Pool Fellowship by Ministry of Science and Korean government. And today he's going to take us back in history. He's going to actually bridge the gap between the traditional and the modern, the Vedic and the modern science, and how nanocentric characterization would help us to by using ultra-modern analytical techniques. And without much ado, I request Professor Amalnerkar to give his presentation.
Thank you, Dr. Kumar, for your kind words. I'll start now my presentation.
Thank you, sir. Sorry to disturb you just for a second. Before we start, just note for the participant, please enter your question and remarks in the chat box. After the presentation of the Dr. Amalnerkar sir, Dr. Hande will prioritize it by Now, my immense pleasure to invite Dr. Amanerkar sir. Please continue.
Yeah. Can you see my presentation now?
Yes, sir.
Yes, we can.
Okay. So, namaste, distinguished panelists and the participants at this digital platform today. At the outset, I would like to thank Dr. Rajurkar Madam for inviting me to participate in this particular function as a invited speaker. I just expressed my concern to her, stating that I am not a hardcore analytical scientist. I just use the modern analytical tools to understand the structure, property, processing, and application correlations. But then I thought, let me take this challenge, not to show that what I know, but to get inputs from the analytical scientists across India. So my thematic presentation is on bridging the gap between Vedic and modern sciences, nanocentric healthcare revelations using ultramodern characterization techniques. Probably you might be wondering why an electronic man like me has suddenly jumped into bandwagon of Ayurvedic materials, particularly Ayurvedic bhasmas, as as my career path. Well, there is a story behind that. This story goes back to September 2009. And during the Ganeshotsav festival, I received a phone call from Padma Vibhushan, Dr. Vijay Bhatkar. And he said, he calls me, Dinesh, I'm going to bring two more people to you tomorrow to discuss something about bhasmas. I said, who are they? He said, Pandit Vasandrao Gadgil, renowned Sanskrit scholar from Pune, and Dr. Yogesh Bendale, renowned Ayurvedic physician and owner of Rasayani Biologics Limited, which manufactures Ayurvedic pharmaceutical products. I was a little skeptical what I had to do with the Ayurvedic bhasmas kind of things. I didn't want to get involved being an electronic materials man and the Director General of the three Center for Materials for Electronics Technology. I didn't want to get in any controversy, but then it was very difficult for me to say no to Dr. Bhatkar, because Bhatkar has specially obliged me and CMET when we just had a beginning. He was the Director General of CELAC and he helped us on several occasions. We developed a good rapport with Dr. Bhatkar. I said, okay. So next day, a team came in the evening, Pandit Vasandrao Gadgil, Dr. Bendale, and Dr. Bhatkar. So I asked Dr. Bendale, he is a friend of my cousin from Amalner. Basically, I belong to Amalner, a place near Jalgaon. Professor Patil sir probably knows that I'm from Amalner. Dr. Bendale is from that area. But I didn't meet him before. What Dr. Bendale, I asked him, what is your interest in our characterization techniques? He said that he intuitively felt that because of the typical process of making bhasma, that is bhasmikaran process, which involves slow grinding for several days or maybe several months and sometimes several years, he felt that these bhasmas might be containing nanoscale materials. So he asked Dr. Bhatkar, who can analyze my materials? Dr. Bhatkar says, it is Dinesh who will do all such analysis. So I asked Dr. Bendale, you said that you have Rasayani Biologics Limited company in Pune, but you have some equipment. I heard that he had ICPOS and he had a GC, he had thermal analyzer and FTIR. But this equipment I thought probably may not be useful. He wanted me to use his equipment for his bhasma analysis. I said may not be useful because probably would go for non-destructive or minimum destructive techniques to retain the pristine state of nanoscale materials in the bhasma formulations. That was an idea. That was a dialogue between me, Dr. Bendale, and Dr. Vijay Bhatkar. So he said, let's go ahead with this. I have no problem. So he has given me a sample of tamra bhasma. It means something related to copper. We analyzed. We had a brand new FESEM in those days. So 2010, we have done some analysis, but unfortunately, we could find there were nano rods, there were nanoscale ribbons, but all made out of calcium, nothing to do with copper. So the experience was a bit frustrating. So I told Dr. Bhatkar and Dr. Bendale, there is a problem. So I just kept the problem aside for quite some time till when I was on verge of my retirement. See, the problem was there on the back of mind all the time. We had all the modern characterization techniques with us, but what was rather kind of illusion for us, we wanted to see some metallic composition in herbometallic products like bhasmas, but could never get initial success. So I said, okay, let me wait for some time. When I was on the verge of retirement, I again opened a dialogue with Dr. Bendale, and I told him, now you give me your all bhasmas, but this time no Tamrabhasma. So he has given me Swarnabhasma, Rajatbhasma, and Jasadbhasma for analysis. Immediately after my superannuation in November 2014, I could get an opportunity to work in the nanotechnology laboratory in the Sangyungan University, that is in South Korea, and then Institute of Nanoscience and Technology in Hanyang University in Seoul, South Korea. These two universities are world-class universities, particularly Sangyungan University. Probably, I don't know whether you can see it, but it was established in 1398, as early as 1398. And now it is one of the leading universities on a global scale. I think its global ranking is something like 85 by this date. For the last couple of decades, this Sangyungan University is controlled by Samsung Foundation to the extent that the chairman of the Samsung Foundation decides who will be the next vice chancellor of Sangyungan University. It all top of the line, state of the art equipment in this particular university. So I decided to use the experimental analytical techniques there to understand what is there in the Bhasma compositions given by Dr. Bendale. Hanyang University also has a good setup. In 2015-16, I was at Sangyungan University. Hanyang University 2017 and 18, I returned in 2019, and now because of COVID got stuck here in India. I'm still visiting professor at Hanyang University, but they had very good equipment related to atomic force microscopy, but I have not really used their facilities to that extent for Bhasma analysis. So gold, silver, and zinc-based Bhasma compositions, that is Swarnabhasma, Roupyabhasma, and Jasadbhasma, were prepared by Dr. Yogesh Bendale in accordance with traditional protocol. He followed traditional Rasa Shastra to produce all these bhasmas. And the bhasmikaran process is heating certain herbometallic compositions several times at high temperatures, 700 to 800 degrees Celsius. That they call it putta. You have to give put after put. I don't know whether you understand the word putta. Putta is in Sanskrit, putta is in Marathi also, maybe in Hindi. So he prepares gold, silver, zinc-based composition in his own company. He personally supervises. It takes a lot of time to make this kind of compositions. Okay, then I got samples, and I had Sri Ganesha at Ultramodern Instrument Laboratory in Sangyunkan University. It's also called as SKKU. So what are the techniques? Normally, all of you know that X-ray diffraction is required for phase identification and to determine the phase purity. Field-Emission Scanning Electron Microscopy is required to understand the morphological features, particularly the shape, the size, and the texture, which could be of much importance in the analysis of bhasmas. X-ray photoelectron spectroscopy, yes, it's good technique for chemical to understand the chemical composition, although confined only to surface and subsurface level. Transmission electron microscopy is very good to understand the fine scale microstructure of the materials, and most importantly, what I have seen there, the technique called scanning transmission electron microscopy with high angle annular dark field as an EDS, energy dispersive spectroscopy elemental mapping technique. The STEM is required to get like TEM or HRTEM to get the high resolution image, but STEM half EDS mapping generally required for getting the high spatial resolution for the atom to atom chemical material, chemical matter in or chemical atoms in the material. So that was the idea, to use STEM hard EDS technique, which is rather new in 2015 to me. CIMET also purchased subsequently TM STEM hard with ILS facility, But at that, when I returned for some time in 2016, my own student who's working on STEM hard said he was not so much aware of the usefulness of this particular technique. Now he has been routinely using this technique. Okay, let us see whether we are successful or not. These are X-ray diffractograms of Swarnabhasma, which just says that it just revealed the presence of FCC, phase-centered cubic, just gold in that. We didn't find any extraneous phase in that. It means it is a phase pure material. And we did not find any other oxide or any other inorganic material to that extent. Whatever limit is there, up to 3% of X-ray diffraction, we did not find any other material in Swarnabhasma. So is the case with Roupyabhasma. Roupyabhasma, we could detect again only phase-centered cubic structure of silver. There is a phase purity. We did not find anything else in that. And the sharpness of the X-ray diffraction peaks indicates the highly crystalline nature of or bhasmas. But in case of zinc oxide, just bhasma, what we observed, we never knew that just bhasma is just zinc oxide, because Dr. Bendari said he starts with zinc ore as such and gets into zinc oxide. He never knew that this is the composition. When we have taken the X-ray diffraction, it revealed the presence of hexagonal zinc oxide, and we did not find any other material of significant consequence in this particular X-ray diffraction analysis. Then what is the next? Next is, of course, to get the SEM images. Unfortunately, my Korean student, he has used the secondary electron mode of imaging, and that's the reason we did not find the better images. Also, there's another problem. I guess there might be some charging here, because normally gold is conducting. You cannot have any charging as far as gold is concerned. On the contrary, for SM analysis or FESEM analysis, if the material is insulating or semiconducting, we need to put gold coating or silver coating on that to avoid the charging. Here, there was the other way around. We could not get, we could not get the read of charging this particular case. So what I have seen here, maybe this is nanoscale gold, this is nanoscale gold, nanoscale gold, maybe combination of the spherical particles. Then there are some faceted particles, distorted faceted particles, which are embedded in an insulating matrix, and this insulating matrix might be creating a kind of charging phenomenon within our sample. So nanoscale materials here are embedded in the inorganic matrix, which we felt that must be amorphous in nature, because you go back to X-ray diffraction and we didn't find any other phase other than the metallic gold FCC structure. So that was a conclusion. It must be something else. What it could be, maybe some inorganic ingredients. There's a temperature involved. Obviously, you can't expect any organic to retain as a result of multiple times heating of this final composition. So that is the reason we felt that nanoparticles or nanogold embedded in the amorphous insulating matrix, creating complications to SEM images. Okay, so same thing is true with the Roupyabhasma sample. Here we could see some kind of faceted grooves. We can see the irregular shapes and the particles of silver. Picture is not contrast. Atomic number contrast we did not get very good because the problem is secondary electron imaging and the charging. But here also we observed the particles are embedded in an insulating inorganic matrix, which is amorphous in nature because nothing has been detected in the X-ray diffraction. Now, since we are not happy with the FESM results, or so-called SEM results, we switched over to transmission electron microscopy to acquire the largest understanding of what is happening within our material. Look at this low magnification, medium magnification, and high magnification. What are limits my student could understand, because he has done by himself and did not allow me to come inside because only one person was allowed to do so. So we could see here there's a good contrast image in TM. You can see this is the nanoscale gold here, nanoscale gold. You can see the faceted growth, the spherical particles may be entrapped in an amorphous inorganic matrix. Why I say so? There is a reason for that. Here it is very clearly seen. There is a gold nanoparticle inside the amorphous insulating matrix of some inorganic material or combination of inorganic materials, which we don't know. So what we have seen here, there's a polydispersity, irregular shaped particle. You can see the particles from nanometer scale to micron scale. So a lot of polydispersity. Of course, there is no mechanization involved in that. Obviously, you cannot have control and cannot get the monocyte distribution of the nanosized materials in this kind of a bhasma. This is the case of Swarnabhasma. Okay, now this is important. STEM HART technique, as I said, to acquire the spatial resolution of atom to atom chemical mapping in the material. This is the STEM image, scanning transmission electron microscopic image. You can see a good contrast here. And this is definitely gold. Look at here, this color. This is a gold. So this spot is gold, this spot is gold, this is gold, this is gold, this is gold, this is gold. You can see the spots here, 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 everywhere. Okay. Now you can see that there's some kind of a carbon, obviously expected in this kind of biogenic synthesis involving use of plants, herbs, shrubs, and biological materials. And you can see here oxygen is everywhere here. This calcium is everywhere here. And this magnesium is also here. But much more is calcium and oxygen as if it is calcium oxide. And here it is gold. We can clearly confirm in the elemental mapping. So we said that X-ray diffraction is very clean, just metallic gold. But this image indicates the presence of a kind of oxide, calcium, oxygen, magnesium, oxygen, in what form that we don't know. We didn't get any oxide formation or any solid state mixture formation in our X-ray diffraction. So this is a composite image. It's the same image. In addition, we have seen CU everywhere. We didn't know really whether the CU is coming from the grid which we have used for the TM analysis, TEM HARP analysis, or it might be the part of the material which has been given by Dr. Bendale to us. Most importantly, when we have taken the ELAX data, we could see that oxygen is the main component. Oxygen, we cannot say that this oxygen is elemental oxygen, maybe atmospheric oxygen. Followed by oxygen, there is a copper. Again, the source is not known, whether it is a grid or whether it is the material itself. Then carbon, calcium, gold, and magnesium. Believe me, this kind of analysis probably just gives some surface and subsurface. And doctors, in laboratory, he confirmed that there's a good amount of gold, maybe assay he has performed by some destructive techniques, and you could get very good results there. But what we observed, the picture like this. This is the true analysis of whatever we have done in Sungkyun University in South Korea. This is about gold. Now, coming to the Roupyabhasma, what we can see here, this is low magnification, this is medium magnification, high magnification image, probably polydispersity of irregular shaped particles. We can see this polydispersity right from nanometer scale to a chunk of micron and submicron scale, irregular features, there are spherical particles, then distorted faceted growth, all sorts of features we have seen in this TM image. And this is STEM HARP EDS mapping, is very interesting data. Here also we can see, for example, where is silver here? This green color. We can see this is a silver, this is silver, 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 silver. Everywhere there is silver. There is oxygen. Everywhere there is oxygen here, like this. There's a calcium everywhere. Most of the places, calcium here. Copper. Unfortunately, we have seen copper also at many places. Magnesium, little bit reduced, and when you have taken composite image, it looks like that. Again, this is the ELAX data. Oxygen is the main component. Just earlier case it was 48%. In this case, this is a little less than 40%. Followed by oxygen, there is a calcium, then copper. Again, source is unknown, whether it is a grid or whether it is Dr. Bendale's material. We don't know. Magnesium, silver, and this is all wet percentage we have done. So we could confirm the presence of oxygen as a major component, though we have not seen formation of any oxide in X-ray diffractograms of either Swarnabhasma or Roupyabhasma. But then when we just analyze the TEM data of the Jasadbhasma, we could again see the polydispersity of facilitated growth. Facilitated growth morphological features is a well-known characteristic of zinc oxide nanomaterials. This is zinc because this just shows that this is Jasadbhasma. It's actually zinc oxide. And again, this electron image, the stem image, very interesting. You can clearly see the faceted growths here. The faceted growth here, distorted faceted growth here. And when you compare with the elemental mapping, you can see oxygen everywhere, oxygen, 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 zinc, zinc, zinc everywhere. So there's a zinc oxide. But suddenly this particular patch, if you look at it, at this particular patch, there's a silicon and there is oxygen. So it must be silicon, kind of a silicon oxide must be present here. So zinc oxide everywhere except this patch, which tells you that it must be silica. And when we have done the EDAX analysis, this is in order. Zinc is more, oxygen less, and this is expected in case of zinc oxide based Jasadbhasma. Okay, the most surprising result in the X-ray photoelectron spectroscopy, when you have taken the survey scans of all Swarnabhasma, then Roupyabhasma and Jasadbhasma, what we could see here, this is the survey scan, oxygen O1S peak is much more intense in Swarnabhasma and Roupyabhasma. And this is, of course, as per expectation. Unfortunately, my Korean student did not pursue further analysis of, getting the high resolution scans, deconvolution. He has not done anything. I was unable to tell him in a proper language what is needed further. But this was surprise. You can't expect O1S to this extent in the X-ray spectra of any material unless and there is an reactive oxygen involved in the compound. You can't expect atmospheric oxygen to give this kind of signal in XPS, because all of you know that X-ray photon spectrometers, they operate at very high vacuum of 10 raised to minus 9 to 10 raised to minus 12 torr. Obviously, you can't expect any atmospheric oxygen to be detected by this kind of analysis. So what is this? Zinc we can expect because zinc oxide formation already confirmed by X-ray diffraction. But X-ray diffractions do not agree with the formation of any oxide which has been detected by X-ray diffraction. So what it could be? Is there any mysterious bonding between the gold and the atomic oxygen in Swarnabhasma, or mysterious bonding between the silver and the atomic oxygen in the Roupyabhasma or Jasadbhasma, whatever we can call? And indeed, we could find a paper. The title of the paper is The Mystery of Gold's Chemical Activity, Local Bonding, Morphology, and Reactivity of Atomic Oxygen. The paper has been published in Physical Chemistry, Chemical Physics by famous nanotechnologist Cynthia Friend. She is very renowned nanoscientist. And what she claims here, she says that there is an extremely reactive nature of atomic oxygen bound in threefold coordination with metallic gold. And this specially happens at nanoscale. So there is a bonding of extremely reactive atomic oxygen bound in threefold coordination site at nanoscale metallic gold, or maybe nanoscale silver. That was our conclusion. So what we did, then we have done again, we have repeated the experiments using National Chemical Laboratory facilities. When sometimes I return to India to spend few months in India, so I pursued Dr. Bendale and his colleague Dr. Nathu, who has very sincere follow-up. Unfortunately, he expired because of COVID last year. So it is Dr. Nathu who, in my absence, he collected all the data. This is again a survey spectrum, definitely indicate against the predominance of O1S peak compared to all others. And this is the O1S. You can see the after deconvolution, whatever is available. Carbon is just for carbon correction we have done, and then we are not very much interested in understanding the biological product. See, biocompatibility is important. But biocompatibility, once it is achieved by the typical process of the Bhasma formation, we had no problem to look at the carbon analysis. But right now I kept this problem aside. Most importantly, somebody said there all the Ayurvedic Bhasma preparations typically involve the usage of mercury. In their language, mercury is called universal solvent, yoga vahi. But trace of mercury has not been seen anywhere here or in the rest of the two X-ray spectra also, which I'm going to show. So absolutely no presence of mercury. But Dr. Bendale said he uses a lot of mercury to make these materials as per traditional Rasa Shastra. So no mercury. That's what we confirmed. So at least there's a relief. Many people are skeptical about the mercury, but Dr. Bendale said that mercury has a problem. Even if you drink mercury, nothing happens because there's no systemic absorption of mercury in all the cases. He said, you give me a glass of mercury, I will drink it in your front. Nothing will happen. It will be thrown out to excreta. That's what Dr. Bendale said, but of course we never did that experiment. So this is gold. Now you look at AU4F core level of gold. There is a doublet structure, and after resolution, you can see it. After deconvolution, you can see here the two peaks here to properly deconvoluted peaks. So what we can see that this peak, 84.2 and 87.9 electron hole express peak, belong to metallic gold, and 85.4 electron hole and 89.1 electron hole probably can belong to kind of oxide between gold and oxygen. So this is a very important clue. We really didn't bother about silicon and phosphorus at the moment. So what we have done, we have seen the possible assignment in case of Swarnabhasma. O1s indicates the presence of surface oxide with this particular binding energy value. This binding energy value indicates presence of subsurface oxide. This I said, this value indicates metallic gold. This value indicates metallic gold. And this value and this value indicate gold in the composition of oxide or Au2O3. Percentage wise, probably it's the same. Oxygen concentration is much higher compared to anything in closely matches with the FESEM, ELEX, and TEM, STEM, HARP, elemental mapping data. So this is about gold. Yes, silver also same thing we have seen. The predominance of O1S signal compared to all others. Here also we could not get any signal of mercury, but we didn't get differentiating peaks like the earlier case, like the gold in case of Roupyabhasma or Jasadbhasma, and we didn't pursue this analysis further. I am just trying to understand what is happening here. Okay, silicon and 2P will skip. Again, we can see here the predominance of O1S, which is in agreement with the data generated by FESEM, EDAX, also STEM, HARP, elemental mapping data. And this is the Jasadbhasma, or to be precise, zinc oxide XPS. Everything is in order. This typically indicates there is a formation of proper hexagonal zinc oxide in conformation with the XRD data. So this is all about the express analysis of Jasadbhasma. Nothing specific, nothing important as far as we are concerned. Okay, this I will skip. Now, these are possible assignments. Maybe there is one more compound here which we could see. We could see the presence of zinc oxide at various energy levels. But this particular O1S at 532.2 electron hole indicates probably zinc hydroxide is present. We could also get substantial quantity of residual organic carbon in our material. Silicon, which we observed earlier in STEM HARP elemental mapping data, did not, we could not get to that extent. No possible assignment of silicon and oxide. We could get it using our data. We're trying to understand what is happening here. Okay. Now this is the concentration. Nothing great about that. It's a normal analysis. Okay. So we said that a kind of mysterious bonding or maybe kind of bonding takes place between the reactive oxygen and the gold. I'm giving this example of gold to form a subsurface oxide like Au2O or AuO2O3. Then what next? There is a reactive oxygen generation. What is reactive oxygen species generation? What are ROSs? Probably all of you, I don't have to tell you, people know very well the importance and the problems with the ROS. Reactive oxygen species is a dual-edged sword. It can allow the cancer to spread. At the same time, reactive oxygen species can kill the cancerous cell. How? Let us try to understand a rather physical chemistry or chemical physics aspect of it. Okay, we said that AU2 or AU2O3 like material has been formed with very small band gap. Maybe band gap is of the order of 0.83 electron volt, because this is, I think, not stable. It gets converted into AU2O3, and the band gap is 0.83 electron volt. The electrons, even at the room temperature, it is possible to get excited electrons in the conduction band, which react with oxygen, form the radical oxygen, that is superoxide, and the holes, left out holes, react with the water, form radical hydroxyl, and there's a reaction between the superoxide and hydrogen ions to form the hydrogen peroxide. So we have superoxide, we have hydroxyl ion, and we also have hydrogen peroxide, which we consider are the important ROS materials. Now let us see what is the relation between ROS and the nano-bhasma, or whatever nanoscale bhasmas containing nanomaterial, and the cancer cell. This is just an illustration. This is a normal cell, and this is the cancer cell. This OS means oxidative state. This is a chemotherapeutic agent, but don't look at this. We can consider that this is our kind of a bhasma. So what happens, whether it is a normal cell or cancer cell, moment the bhasma containing nanoscale materials comes in close contact with the normal cell, there is ROS generation two-way. There is a pro-inflammatory response of both the cells, normal as well as cancer cell. This is a pro-inflammatory response, which generate ROS to kill the unknown particle. At the same time, Swarnabhasma in the composition of, say for example, AU2O3 or AU2O can also generate its own ROS. So there's a huge ROS getting accumulated, and by any chance, if it goes intracellularly, there's too much of an intracellular accumulation of reactive oxygen species in the normal cells likely to take place. But normal cells have antioxidant enzymes. This reactive oxygen species are oxidant in nature, and that's why they could probably damage the normal cell. But the body's own defense produces antioxidant enzymes, and there is a good balance of antioxidant and oxidant in case of normal cells. So normal cells are intact. This is called what is cytotoxicity, selective cell toxicity. This is cytotoxic only towards cancer cell, but cancer cells do have a lot of ROS generated inside intracellularly, but both ways, maybe by entering inside and exogenously, but they don't have antioxidant enzymes. That is the main reason there's too much of oxidative stress, and which ultimately leads to death of cancer cells. How? Let us stay in this schematic. This is oxidative stress level. This is normal cell, good balance between antioxidant and oxidant. Even if you have ROS generating drug, including our bhasma, nothing happens here. Well, slowly, cancer cells also, if there's not too much of ROS, there no problem. Still, oxidant is more, antioxidant less, but when it goes beyond, it crosses certain threshold level, that leads to cell death by apoptosis. That is what critically we have seen. This is called critical threshold, redox threshold. So this redox reactions is very important